To welcome this huge crowd to one of the last sessions of LCA 2012. Our speaker today is Dario Freddi, a senior software engineer and project manager contributing to KDE. He's now a member of EV, which is the foundation that supports KDE, and Dario's a KDE core contributor. Besides KDE, he works on several open source projects, including telephony, and specializes in freedesktop.org technologies and integration. Please make him feel welcome.
Thank you very much, and thanks for skipping your coffee for coming here, because most of the people are still drinking stuff and all the rest, so I really appreciate your presence. So, actually, this is my second talk at this conference, so hello again for any of you who was there. I don't really remember your faces, so maybe you are not. But, I mean, organizers are so cool that they provide you an introduction, so I skipped this part, and I mean, this is everything you don't know about me. That's my passport, and this is my face. So everything else he told you. And today I'm going to talk about social applications. So what is a social application? I mean, multiplayer application maybe? Like something which multiple users use at the same time, community application like a group of users, or something like that, or anything. I mean, social is just a buzzword, and nothing more than that, but it's a very popular buzzword. I mean, just look at that. This is the first picture I found with a decent license, which actually shows up how the social media landscape is drawn out these days. Now, you probably know Twitter, Facebook, and whatever else, but there are a number of social networks around that most of us don't even know, and people are using them. Maybe it's a very local thing, like people in some countries use a special social network or stuff like that, and we don't even know about this. But why? Because people expect interaction. Now, the position of this talk is quite unfortunate after the keynote today, because I'm talking about something totally different. We've been talking about privacy before, and I'm talking about people who are actually wanting to share stuff. We all do that. I mean, as much as we care about privacy, every time we post on Twitter, every time we post on Facebook, on Google+, and I harshly doubt that somebody doesn't have this anymore, at least at this conference, we are sharing our data. We are willingly giving away our data to the people because we want to. So privacy is an issue, but we also should consider that people don't want privacy sometimes. They reject that. A social world is actually what is the thing we are confronting us with. Because instant messaging has become way, way more popular than email. I mean, we all use email. I use email a lot. But I use instant messaging with my friends. And the barrier that the real target I have to aim to, it's my friends and not developers. Because my friends are more likely to use my software. Sharing is important. Twitter, Facebook, and all the things are actually all about sharing. And everything should happen in real time. And what is open for us? I mean, the problem is that social networks are very, very close pieces of software. All of them. All of the most popular. I mean, we have Identica. This is a great thing. But I don't know of any other social network which is that open as that. But diaspora maybe, but it's not as widespread. I mean, Google+, Facebook, and Twitter are the main stakeholders, and they're close, although they are advertising public APIs and stuff. But luckily, we have something. And it's the things I'd like to talk about today. There is a way we can at least use these social networks to do something open and something good for everyone who's has a Facebook account, Google account, or anything else. So the first thing I want to talk about is telepathy. Now, what is telepathy? Telepathy is this. Maybe you didn't expect something like that, but this is pretty much how telepathy looks like. Telepathy is multi-protocol. Telepathy is completely dbus based. This dbus service here is your dbus daemon, your friendly dbus daemon, and everything else happens around it. And telepathy is complemented by high-level client libraries. So we have Qt libraries, glib libraries, and pretty much you can do yours if you have a different toolkit or a different programming language you want to support. We have Python bindings and stuff like that. But most of all, it's a framework. It's not an application. It's a framework which can be used to build complete full-fledged messaging solutions like KDE Telepathy or Empathy. And I'm sure that probably most of you run one of these two softwares on your PC, and they are built using telepathy, but they are simply a front end to the framework. How? Tubes. Tubes are what I really want to talk about today, because tubes is something that can be used for gaining features which are social in your own applications. Now, what is a tube? A tube is something which opens a data channel with a contact, or multiple contacts. So tubes can be one-to-one or one-to-many. It's actually perfectly supported by Gabl. Gabl is the name of the connection manager which supports Jabber and XMPP, so free protocols. Guess what? But it is two clients supporting the same service. So we are basically building applications which advertise the service, much like a multiplayer game or whatever else. You advertise the service over TCP and stuff, and the other client gets it. This is very close to that, and we will discover that it's much, much more similar than you imagine. So there are two kinds of tubes, stream tubes and dbus tubes. Now, today we're going to just talk about stream tubes because, I mean, I don't have time to talk of everything that I want to talk about. I will need like 3 or 4 hours for that. But we'll try to do something anyway. Stream tubes are basically something which offers properties similar to SOC stream sockets. So yeah, it's a full-fledged socket. You got it right. And each tube advertises a service. So what it means, a tube is a way for starting up a service over an IM connection with a contact in a way which is totally transparent as a socket. So you're actually opening a socket from your perspective. And each service can be dbus activated, which means that your client doesn't need to be alive to get the message. Now, the XMPP support I'm talking about is basically using a specification which is XEP95. Now, I won't talk about it because you should actually grab your books and read it if you're interested in. But the interesting stuff is that it can fall back to in-band bystream. So this means that whatever version of telepathy and connection manager you're using, you can still fall back to something which supports your approach. Be it very fast, like 95, which actually opens up a full out-of-band stream to the other peer. So it's a full-fledged peer-to-peer connection, or in-band bystream, which is, of course, very slow. So everything I'm talking about is very cool, but it's just an implementation detail. Now, tubes abstract all over these things. This means that I'm talking about XMPP, Gabl, Jabber, and this stuff here, but everything I'm talking about is totally extensible to other protocols, if it will be ever possible. Of course, Gabl, so XMPP, actually supports this feature by design in the protocol itself. There is a way for implementing this feature in other protocols, but it's not as fast. But in the future, it might be possible. And this all depends on how widespread the feature will be. Now, this is pretty much our infrastructure then. We have a server and a client, which are just your PCs. And a PC with an IM client is actually your server or your client. We have the network and connection managers taking care of instantiating the socket between the two ends. But, I mean, you might be starting to wonder how this all works. Let's have a quick look at how telepathy works then. Telepathy, as I told you, revolves all around dbus. Being revolving all around dbus, all of these clients, connection managers, and account manager, channel dispatchers, which we will see in a minute, are totally independent one with the other. And by independent, I mean they can be actually separate applications. And they most likely are. So there is one thing which is called mission control. Mission control is basically a daemon which is persistent and takes care of all the dispatching logic. So mission control is capable of starting new channels when there is the need to. Mission control takes over the account control, so you can look up your accounts and whatever else. Mission control is totally transparent, most of all, and your application, if you're using a client library, won't even know it exists. Mission control is very silent and takes care of all the logic for bringing all of your components up just when needed. And of course, this doesn't mean that you have to care about this, because everything is done behind the scenes and through dbus. Now, handlers, what are them? A handler handles a channel, surprise, surprise. And it's invoked when mission control receives a request. Now, a channel in telepathy is something which is basically a connection between one contact and the other using any possible kind of channel type, which is text, for example, video chat, for example, a tube. And this is why we're talking about handlers now. And it's responsible for taking care of this channel during its entire lifetime. What is this? This is a handler. This is a handler for chat. So if you are basically using a text chat, this is what a handler looks like, a simple chat viewing application. This one is a separate binary. And it's not invoked by the contact list. Mission control does it completely transparently. And we will see why and how in a few minutes. So this is what you've just seen. Now, creating a handler. We're going to try to do it now. And I will show you how you do it with a small demo afterwards. Now, our handler should handle stream tubes, which refer to a specific service. We are using telepathy Qt for doing that. So it's one of the two main bindings to telepathy. So the first reason why I'm using Telepathy Qt is because I like Qt. And the second reason is because I want to advertise this new neat feature, which I hope will surprise you. And it's the new server and client infrastructure we have for tubes. So this infrastructure is hiding all the dispatch logic. So you don't need to care about when a tube is dispatched, when a tube is received, or whatever else. You just need to care about which socket you're exporting. Creating a server or client sets up your handler. So back in the days, and still with other channels, we need to set up specific handlers, implement the logic behind those, behind the acceptance of the channel and this kind of stuff. But client and servers of Telepathy actually take care of all of that on their own. And this means that a tube handler can be set up in a very, very small amount of lines of code. And I'm going to show you later. So this is the main way you create a tube. It's one line. Okay? So once you instantiate your StreamTube client, you simply create. And that's it. The parameters are just used for advertising the services your client is going to support. So the first argument here is for services supported by peer-to-peer connections. So my peer-to-peer connection is going to support RFB as a protocol. The second one is for group connections. So I can even handle separate protocols for one-to-one and one-to-many connections. This one is the name of our client. And we will see why this is important later. And with Trubo, you are actually monitoring the connection, but it's not something you are much interested in. The most interesting part is that by this function, you can simply create a handler by saying, hey, I want to handle RFB with my client named this way. As easy as that. And once you've done that, it's very easy. String tubes can be accepted in two ways. As a TCP socket or as a Unix socket. You might say, why? Well, actually, tubes are very useful if you're replacing logic in your application. So suppose your application is using a TCP or Unix logic for doing anything. You can simply decide which kind of socket you will get and replace your logic without even touching your logic itself. That's incredible. And so, yeah, basically, the nice thing is that this doesn't affect how the data is handled. This is just the interface you're using for assessing the channel. But you can transparently choose between TCP and Unix to your liking. And at this point, you just need to wait for your tube to be automatically accepted. This is going to be called for you every time your client will be invoked. Now, you might start to wonder, wait, this is not really secure. This means that anybody who requests a tube is actually going to open a channel with me without me even knowing. I mean, this client is easy, but it's, creepy, because anybody can connect. And this is why approvers exist. What's an approver? An approver is used to accept or reject incoming channel dispatch operations. This means that if I'm opening a channel with you, your desktop might be saying, hey, wait, there is somebody named Dario which is trying to open a channel with you. Do you really want that or not? Now, the reason why I'm not showcasing this here is because your desktop environment already implements an approver, very likely to be. If you're using GNOME or KDE, it's guaranteed you're using an approver. If you're using other desktops, probably you will be in the short term. But the nice thing is that a handler can be his own approver. This means that if your handler, like this one, requires some stuff and some constraints to be fulfilled by a request, you can implement your own approver. And the great thing is that you can have multiple approvers for the same service. So many things can decide whether the channel is going to be accepted or rejected. So through this infrastructure, you can always control if the user wants the channel to be open or not. And this is pretty much how a very basic approver looks like. A notification telling you, hey, somebody wants to share its desktop with you. Accept or reject. Now, you might say, hey, wait, this is not something you can do with IAM. I'm sharing a desktop. This is something, you're tricking me. I want my money back. Well, first of all, you didn't pay me. And second of all, this thing is actually using tubes. So, handler filtering. This is a client descriptor file. We are using this for tracking the properties of our handler. Now, do you remember when I've been talking about opening a new tube, so creating a new client, that we mentioned the name of a specific client? Now, the name of the client is the name of the descriptor file. These files are installed so that Telepathy knows a handler exists. So, this is how they look like. Every handler can implement, every channel actually, and every client can implement a number of interfaces. Now we are implementing the handler interface. And we can specify a number of channel filters. What does it mean? We can tell Telepathy that our client is handling a specific set of channels. In this case, we are telling, hey, we are handling stream tubes with RFB service and which are not requested by us. What does it mean? That these channels are always incoming. So it's always somebody else who opened up a connection with us. Now, if you start to think about it, all of this picture starts making sense. Because your code is not doing anything besides advertising at install time its capabilities. Mission control takes care of reading all of these files and saying, hey, I have this specific channel, and the handler filtering rules tell me that this specific application should handle it. Let's start it up, or let's use it if the application is already on. And once we've done all of that and we realize that the tubes are going to come to our application, this is what we get. So if you remember, we've connected two functions to get the tube when it was accepted. Now, upon acceptance, you basically get the listening address and the listening port. So you can start building your socket from the beginning. I mean, you just need these two information. But you also know where it's coming from, the account the connection is coming from, and the low-level channel pointer if you wish to do some other operations. But for a very basic functionality, as we're going to see in a few minutes, just the first two arguments are going to be useful. Because you simply set up your socket and you forget about the fact that the socket is being streamed over an XMPP connection. You don't care about that. Your application doesn't care about that. And when the tube is accepted, the socket is ready. So when this function is going to be called, your socket is ready to be used. So we've seen a client, but is a server that different? Well, the answer is no. Because in a server environment, you simply have to create your socket and export it. So if you have a listening socket, you can call this function on your tube server, which you build in the same way, and export your listening socket. And that's all you need to do. And handling happens in the same way. And if you've been listening closely, this also means that the application requesting a tube is not the handler. Or basically, it can be the handler, it cannot be the handler, depending on your liking. So you can do requests from a contact list to open a specific tube by an application which doesn't even know is going to be the server, but he's going to be the server anyway, even if the request was started from another application. Now, the StreamTube server does handling, whereas the request is done through accounts by creating new channels in a very similar way. So in this case, we can also specify the name of the handler. We do that because we want to make sure that our application gets this request. But if we left this field blank, then the handler filtering magic is going to be happening in mission control, and mission control will take care of saying, hey, this application is the one we want. Or we can use insurance handle, which is very useful if you want to open a very single channel towards a single contact, which basically doesn't create a channel if already one is existing, and it handles it directly, so without specifying the handler itself. The result, so if you have ever used desktop sharing in KDE, you probably are familiar with this window, but the strange thing, you don't really see the address here, but the fact is that the connection is all happening through tubes. So this desktop you're seeing is being shared over an XMPP connection by using the logic I've just shown you. It's just pretty amazing. And it's great for games, because if you have a game, making it multiplayer is very easy. But you might say, okay, maybe in a game I want to share my iScore. Is there something that can let me do that? Yes, Libsocialweb. Libsocialweb takes care of the other part of the social word we've not been talking about, which is sharing. I've been talking about this in the beginning, and this is how it's done. Libsocialweb is very similar to Telepathy. The architecture is pretty much the same. We have a daemon, a number of clients, and the number of sources instead of connection managers handling a specific service. So Flickr, Twitter, Last.fm, Facebook, you name it. Now, the architecture is very similar, but it's for sharing. Each service can be configured once. There is no such thing as mission control. We have Libsocialweb core, which is just a daemon, which is loading plugins instead of loading services standalone. And pretty much the use case is way more simple. I guess you can understand it. But it's way scalable, because sharing services are very simple. You need to update, you need to read, and you need to pretty much list the context if you really want to. And client libraries, in this case, are much more of a direct interface to the bus. Now, I don't want to talk a lot about Libsocialweb because it's so easy that I don't even know why I'm talking about it and not just show you. And this is exactly what I'm going to do now. So, hoping it works, because we know how demos are likely to fail when you're in a conference environment and these kind of things. In fact, I think I should need to restart this before. I'm doing some stuff you should not know in my main PC. So if my 2 local accounts come up, here they go. Okay, perfect. So this is a demo application which is shipped with Qt. It's called Same Game. It's a same game, actually, if you are familiar with the game. What I've done here is basically taking the code as it is and see how difficult it will be to port it to tubes. So what did I do? I did 2 separate applications in which, in the first one, I'm able to enter a Jabber ID of a contact I want to start a game with. Now, hoping it works. I have a local Jabber server on my machine. And this one is connected to the other account I previously entered. So this game is very stupid. Basically, all the clicks from one interface to the other are simply triggering a click in the same position on the other one. Now, I did this just for showing the capabilities of tubes, so I didn't share the patterns because I didn't want to lose a lot of time. But that's pretty much it. And it doesn't end here, actually. Because now, if I can open up a browser, I've added a very, very interesting thing to this high score thing, which is Libsocialweb integration. Now, if you wait for Chromium to start and to be here, okay, Twitter.com. Okay, thank you. Now, if everything works, you should see a simple post by me. Hello. That's my Twitter ID, but I don't really use it. In fact, the password is crap. Now, how do I use Twitter? I go to my profile, I guess. Yes, I guess. No? Do you know how to get to my profile? Okay, maybe I know it.
The profile link.
Okay.
On the screen.
Perfect.
On that link.
Okay, I don't see it. That's very neat. Well, anyway, I will just show you the code and try to start Libsocialweb again. Of course, something didn't have to work. But basically, I want to show you the code to this example, which is somewhere here. Okay, you go this way. Okay, so this file is the one I added to the same game for implementing the logic. Now, the number of lines is 101. Not tricking you. What did I do? Very simple. I just created my client, as I've been showing you before, set to accept, and exported the object to QML. Now, when I accept the tube, you see that I am actually disregarding all the parameters. I'm just caring about this one. Listen address and listen port. And I simply create a socket, a TCP socket, and connect to the OS. I mean, this is simple TCP logic, no IAM logic involved. And I simply listen to the socket. Because from this point, I mean, once this function is called, I don't care anymore about telepathy, about IAM, about XMPP. I just care about the socket itself. And I did a very simple protocol, which is mouse X position, mouse Y position. And I simply read it and stream the messages back to QML. So that's as easy as it gets. I mean, it cannot be easier than that. The client instead, sorry, the server instead, which is on the wrong screen again, we're going to fix that. It's pretty much the same. We're going to create a server in the same way. Now we're going to also ask for some details from our accounts because we want to know the contact we're connecting to. And the logic is extremely similar. We are creating a TCP server in this case. So this class handles a TCP server and creates sockets and whenever a connection is actually made. That's all you got to do. And then you listen to TCP connections. Of course, in this file, we also implemented the logic for starting the stream tube, and that's why we also ask for information about the context. We will not need that if this was a pure handler. But this one is also a channel dispatcher. So we are dispatching the channel out and asking to initiate a tube with a contact with a specific service and with a specific handler. But the logic doesn't change. And once again, we are listening to new connections just to monitor the tube for debug purposes. But the reality is that whenever a new tube is created, we get this lot. And this lot comes from QTCP server. So we don't even need the server anymore. Once we create it, we can just forget about it and keep the TCP server around. Now, this probably lets you understand why I've been talking about porting applications, because it's extremely easy to do that if you have an existing logic. And just for ending everything, this is the QML file of the game. Now, believe me or not, but everything I've added, besides the dialogue, is this. The logic is untouched. I added 3 signals for being able to communicate from QML to C++, and I added 2 functions for handling a click whenever a new click is received, and for starting a new game when the connection is initiated. That's all. The logic is untouched. The game is the same. The main JavaScript file handling the whole logic processing is exactly the same, and how many are those? 10 lines of code maybe. 10 lines of code and you're done. So I mean, porting is easy. There is no reason why you should not do it. And you can replace transparently existing TCP or Unix socket logic. Like this. This thing I showed you before, first of all, it's because it's impressive. Second of all, it's because it's using TCP very, very extensively. So it's a desktop sharing application, you might know it. And again, we just added a single class. And we pass the TCP socket back to the main logic without even touching it. So this is a very good example for that. And this is why I've been showing this before. And adding new logic is not intrusive, as you have seen. So can your application take advantage of that? Now, I really believe that the answer is yes. But in case the answer is no, be creative. Because probably you have a way for doing that, but you still didn't think about it. And why not? I mean, because it's so easy and because your users will thank you for that. And I want to thank you very much for listening.
Thanks for that, Dario. Does anybody have any questions?
I paid that guy for being here.
Sorry, that was a premature hand raise. Yeah, so on the sort of no side of that last question, obviously this is very straightforward for Qt apps.
Yeah.
Is this this is the assumed restriction, or would it be how hard do you think it would be to bridge?
To do it in glib, you mean? Like
say, for example, just had like a simple, say you just had like a simple C app that spoke on a socket, provided some sort of service.
So it will not be as quick as that. Okay, but this is also because you're not using a toolkit. So glib still doesn't have a client-server logic like this one, but creating a handler, I can estimate this to be done in 3 times the lines of code I've been showing you. So it's not something which is out of control if you're not using the new server client infrastructure. Now, we've been using handlers in Qt for a long time, and yeah, I mean, you just have created one more class, basically. That's pretty much it. Same goes for glib.
Have another question down here. It's a small audience, so everyone gets to ask the questions.
I'm not sure if it's a question or more of an answer. I have written a Telepathy Tubes application with GTK, and yeah, like you said, it didn't have the server, and it wasn't too many lines of code. I mean, I don't know how many lines of code it was off the top of my head, but it wasn't all that bad. The hard part was chasing down the documentation.
Yeah,
but
I mean, we are working on that these days. I mean, Telepathy has improved a lot from this point of view. Telepathy glib is getting there. But I mean, for answering the question further, the main thing you are not having by not using this infrastructure is the automatic handling. So you need to create a handler, a real handler, and something which handles the channel afterwards, as in classes, of course. Whereas server hides all the logic.
you sort of need something that speaks dbus. at the basic level.
Yeah. Although I do not advise to do that. Because it's actually, I mean, telepathy is very complex if you go low and low level. So using dbus directly is something I will not advise you to do, but you can.
It's a bit off topic. KDE Telepathy, the next release is due out in 4 or 5 days, I think. Are you involved with that? And can you tell us a little bit about it?
Thanks for asking. So I have good news for that. KDE Telepathy has been moved to Extra. So this means that KDE Telepathy, I'm also saying hi to any people from KDE Telepathy on the live stream, is basically now in a position where it can have a stable release. Now, we are trying hard to get KDE Telepathy in a very good state for 4.8. It will not be part of the main KDE distribution because we want it to be released as a separate component because we need to have some release logic which is separate from main KDE. But okay, I'm trying to be a prophet here. By 4.9, we're going to be replacing Kopit. I hope. We are almost at a point where we can do that. And we are very close.
Any other questions or answers? The slide said don't be shy. It was right.
Yeah, and the monitor went blacked out anyway. It's not my fault.
Well, you still don't have to be shy.
I guess we just missed 2 or 3 people for asking a question, so I'm quite satisfied.
Well, not a problem. Just want to say thanks for a great talk, Dario.
Thank you.
I want to present you with a Golden Penguin Award.
Thank you very much.